Okay, welcome to my talk, Software Engineering Completeness, Knowing Why When You Were Done and Why It Matters. This is actually part one because it won't all fit into an hour. So it'll be a bit of a cliffhanger at the end. All right. First, who am I? Who's this guy sitting up on stage daring to speak on weighty matters? Well, I started using C++ back in 1991, so 33 odd years ago. A long time ago, we didn't have standards or pretty much we didn't have anything. All right, in my professional career, I spent most of my time as system analyst or architect, and I spent roughly 21 years as a consultant. And that just means I've seen a lot of different companies and a lot of teams around me in those companies. So I've seen a lot of what worked and what didn't work. And I was going to say the last decade I've been in Bloomberg, but someone congratulated me on LinkedIn today. It's been 14 years in Bloomberg, which was kind of scary, right? I didn't think it would go that long. And finally, when I give talks at a conference, what I try to do is have it based in the real world, because it's where most of us code and program. And I try and put some kind of new thought in your head or have you think about something a little differently. Right? Try and change how you look or attack a problem. So let's get on with the talk. So what was the inspiration for this talk? And it was roughly about a year ago. I was going to our London office, and I was going to see this character here who's in the audience. Right? His name's Nick Newson, and he was a manager who moved out of our section, but I used to work with. And as I was coming over, he said, "Listen, you do this conference talk thing. I want you to talk to all my new guys." And I said, "Well, here's the menu of conference talks I've done. Which one do you want?" He said, "Well, I don't want any of that stuff. I want something that's more useful." Right? And I said, well, Nick, what's on your mind? What is it? What's on your mind? He said, "Well, I need to talk about the cost of software ownership. What goes into keeping software alive and well?" He said, "Because with my guys, I'm trying to tell them it's not just about writing code. That's one part of it, but it's not all of it." And at the same time, I was running a large enterprise project on migration, and I was having a lot of frustration. I said, well, what I'm kind of ticked off is I have these tremendous problems about asking people when they're done, and when they finally say, "Give me a date," which is not that easy to extract, it's not actually done. We don't have a shared understanding of what I meant. All right, so that's what put this thing into being, and I gave Nick's group about a 20-minute talk, and that blew up when I really thought about it to about 2 hours of content, which you're going to see the first half of. So, in my early career, when I was tasked with doing something, I was asked, "Are we done yet?" A lot. These days, I'm more asking people, "Are you done yet?" Because that's what actually people mean when they say, "Are we done?" It's like, "Are you done yet?" And the answer probably is you're not. You're probably not done. All right, but why is that? Well, that's going to be most, I think, of the first part of our talk. All right, so what does done mean? Right, so the first place I'll go is I go to the dictionary, and it's got a fairly good summary of it. It means to work on something to completion or to a required state that we have agreed on, right? But what does it mean for engineering? You know, and I look around in my group and other places, no one has it wrote down anywhere, right? It's something that just floats around. Where I was able to find a definition of done that was written down was in the Scrum Guide, right, which says it's a formal description of the state of the increment when it meets the quality measures required from your product. It's a formal description of your quality standards. I mean, when I'm looking at concepts and variadic functions, this stuff just flies over my head, right? It's like I don't need to know about this. So it's not very, very descriptive. But why even bother? Why bother even formalizing or writing down what done means? I mean, what use is there? It's just a lot of hassle, right? If I tell you it's done, it'll be done when it's done. All right, it's hard to run an organization like that. So why bother? Well, locally or within your team, if you establish a proper definition of done, it creates a shared understanding and unified language, right, with the people around you. And it ensures that new people coming into your group have access to what is probably tribal knowledge and expectations. So that's what it gives when you talk to your immediate team of what done means. Across an organization, so you go a little further up, a proper definition of done acknowledges we have a shared responsibility to get things completed, and it helps a software organization maintain what we call alignment on projects. And that can be, when you don't have alignment, you can have bad things happen. For instance, I say we're going to have this critical new feature for launch in the market on X, and the marketing department prints a whole bunch of stuff, we're going live with this on X, and a whole thing happens. And then when they say, right, it's the 27th of November, we publish for the 1st of December, we're going live, is, oh yeah, I'm not actually done. My definition of done was I merged it into the code base, for instance. Right, so all this friction can happen if you don't have a shared definition of done. So I'm going to give you a quick example. The goal of your project is to develop 10 new features and deploy them to users, but you haven't deployed anything yet. What is your completion percentage? Correct, Titus. I think you've done this before, right? It's 0. All right? Now, when I say this, someone, might be Nick, jumps up and says, but we've coded and tested 5 of them, so we're really 50% done, right? And I'm going to tell you that is not a very good definition of done because your customer is not being included in what done means. He sees nothing of what you've done, all right? And the real question should be, when can I expect something, whatever it is, to be deployed and active everywhere in production? That means I materialize the value of whatever I've put in. All right. So look, for that shared understanding, I'm going to get a bit of basic terminology done. What is the business value of software engineering? Now, as engineers, business can be a bit of a dirty word, right? It gets in the way of pure, true engineering, self-actualization, right? But, we get paid. So it's delivering desired outcomes in incremental steps. That's what the value of software engineering delivers to the business. Why incremental steps? Well, I think earlier on we did a lot of big bang stuff and it didn't go too well, right? When you do stuff in increments, you have shorter time horizons, so you're more accurate in your predictions. You have lower risk because usually you change less when you have a shorter time horizon and you've broken something up. You get better feedback from customers because you can course correct in the middle of all those increments. And with all these increments coming in, it's important to know the cadence and delivery of these pieces, right, of your project, right? So that's important to know. So when is business value actualized? And this comes back to the example I gave you. Like, when does it actually materialize that we have given the business some value? Well, it's when we give something that's available. So we open our app and there's a new thing on the menu, or we have a service that's now up and running, so it's available. It also has to be usable. It's not good if it's there and it doesn't really do what it's supposed to. And it has to be reliable. Okay? So these things are what you have to give to the customer or your customer proxy for stuff to be actually valuable to the business. Now, this is all stuff that is, I'm going to say, customer-focused, right? The customer, all he needs to see is this. But from engineering terms, there's also software value. And that value comes from having your software to be configurable, meaning I can make it do various things without rewriting the code. All right? But if I do have to rewrite the code, I don't rewrite it, I have to add enhancements to it, that the code is sufficiently flexible to accept that kind of change gracefully. And we should be also able to fix issues quickly, which will come from the one before it, and evolve quickly. So as the marketplace changes, or some competitor comes out with something, you can catch up. All right, so this is what I'll call the business value as engineers we give to software. So what types of improvement do we deliver to production? This is interactive, by the way. I know it's kind of a large hall, but shout something up. I got 100-something engineers in here, and no one's telling me. What do you give to production? Product, yeah, I guess. I'm going to call it, we do new features. All right. What else? Bug fixes, yes, another good one. Anything else? Huh? Yeah, I think that goes into the new features maybe, right? But we deliver feature flag changes, right, which means you switch new things on. So we push code out, but it's not active. We also deliver configuration. Anything else?
No documentation.
Yeah, well, documentation. As engineers, that's a kind of a dirty word. It shouldn't be after Titus's talk, right? But we also deliver tech debt reduction. At least we hope we do. Refactoring, depreciation of code, all right, this kind of thing. And something that I was involved, I gave like roughly 2 years of my life to, was giving new machine architectures, all right? And because we moved to a Linux architecture, we got to a new compiler version to C++20. All right, so these are things we deliver to production. What other types of change do we deliver to production?
Bugs.
That's right. We deliver broken functionality. We deliver missing functionality, meaning we didn't deliver, right? Performance issues. Who's ever put a piece of code in that turns out like it worked, but it tanked the performance, right? Yes. And thanks for admitting to it, Dave. I've seen one where a developer accidentally left a print statement in a hot loop of processing, and the latency went up 3,000%. It was only caught when it went to production. Security issues. We all have a lot of things going on about the security in C++. System unreliability. So these are all things we deliver to production that we wish we didn't deliver, right? So how do we keep them down, the other stuff, flowing more successfully? So what is in a commitment to deliver change? And by change, it's all of the ones we just talked about. I don't want to just talk about features. If you're primarily into doing features, then maybe that's your thing. But what's in a commitment to deliver change? Well, no, testing it is fine, but you have to know what you're delivering first. It's a step that we seem to go by very glibly. We get a rough idea, off down the road, right, 2 miles later, we realize we don't have pants or running shoes on, right? So know what you're delivering. And to do that, a good way of doing is acceptance criteria. But something like that, and what are acceptance criteria? Well, they're conditions your product must satisfy before you're judged as having successfully done something. But it's not you people in the group, your local people, that need to say it's accepted. It's the user or whoever's your stakeholder or proxy. Right? Lots of times we try and be self-licking lollipops. Is that what they call it? Like we ratify our own change and say it's great. When we have someone, we have to identify our customer. So good acceptance criteria should have the following attributes. Straightforward, easy to understand for all team members and the customer. All right. Conciseness, meaning you say exactly what you're trying to deliver. You don't make it vague and slippery and hard to define what you're actually looking to do. Be testable. Right, someone out there said, it should be testable. You should be able to say, this AC is reached when you can test for this. And the last thing, and again, this is something that I think we leave out, it should be observable. I should not need to be an engineer or some sort of template genius to see what I'm delivering, because the customer doesn't see templates, right? At least I hope he doesn't. All right, so you have to be observable. You have to have observability on what you're doing. And one important thing, because a lot of people write acceptance criteria with a lot of how in it, it's supposed to be what will happen, not how it will be affected. That's left to the engineers on their implementation. It's not meant for the person saying what he wants to happen. All right? So acceptance criteria, if you're writing acceptance criteria, who writes it? Who writes it? The man upstairs? Yeah. It can be you or the product owner if you've talked to the product owner. Right? It should be shared with your team, so your team knows what we're agreeing to. Reviewed and validated with the customer. If you're the one who wrote it, you need to go back to your customer and ask, or whoever's the proxy for the customer, if you have a business analyst, is this what you're looking for? And there's a couple of ways of doing it. I like more the give and when then. If someone put prose in, just like a little essay of a paragraph, it tends to have like waffle in it and hard to figure out. So I like to say, here was one scenario I had as acceptance criteria, and I've reference machines that I'm doing QA on, A/B testing, when I was doing this migration. And I wanted to say, look, there are times when the reference machine is bad and it's causing a bunch of problems. So given I have a daily suite of comparison testing between a test and a reference machine, my precondition, when a reference machine has building tag, non-standard software, a bad environment, meaning it's not healthy, then replace that reference machine with a machine from a backup list and repeat this check. All right, so this is what I delivered, so we got better, reliable results of our testing, which we were doing in this large migration project. So let's quickly talk about problem domains, because that affects how accurate you are in your predictions. Where is your problem sitting? So what is the domain of your change? Well, one answer I do get a lot is I have no idea, but we're looking into it. It's unknown, but I have a feeling it's not too bad, right? That's not something I can really work with. Or your domain of your change, your problem is simple. And by simple, I mean it's a known and straightforward solution. There's usually only one of them. There's no external dependencies, and it's low risk. It's like adding a new piece of your calculation in your code. You don't have to coordinate with anybody, right? Simple. Then you have complicated, and that usually has a lot of moving parts. It needs some analysis of what you need to do to fix it. There's probably multiple right answers, and you've got to pick, the rightest of them. All right. But it's not that hard. It really there's a little more coordination involved. Complex is we're getting into hard problems to solve. All right. These have lots of unknowns. They're usually larger projects. They have many external dependencies, many groups that might have to, be in step. And because of that, the coordination involved is large. Right? People dismiss that as, it's just getting 20 teams to walk on a line. How hard can that be? And it's hard getting 2 or 3 to actually coordinate. And the risk is usually high and needs managing, right? Because you're usually on a larger project when you do stuff like this. There is a diagram called the SIN-FIN framework. I think that's right. I think it's Welsh. If there's any Welsh people, I apologize. All right, it just talks about the 4 problem domains. There is something called chaotic. But chaotic isn't really what we do in engineering. That's when we're putting a fire out in production, right? Trying to find the quickest way to turn it off. So to know what we're delivering, we need some requirements and scope. So what is project scope? Anyone got all right, a shy audience. Project scope is the complete list of features or deliverables for a project. Okay, that's what you're promising to deliver. It can also specify items that are out of scope, right? Look, here's what I'm doing. Well, what about this? No, this is not in the scope, and we agree that up front. And these are created using requirements of a project. So what is a lot of, I'm going to say the debt, a debt of a lot of projects is what? What happens to your scope? Right, you get scope creep, right? Insidious, and it's in the early stages of your project, scope creep will kill you, because you'll think you have a lot of time on your hands. You'll agree to do new stuff, which is not a bad thing. If you go, look, I'll add this in, and give me 6 months more, or something like that, right? As opposed to, we'll just absorb. And requirements should specify what the change should do in bounded terms. It's not just, we are going to allow you to trade equities, right? And there's 100 flavors of that we'll never get to. So you got to say, we're going to trade this type of equity in this type of way. All right? And if there's a lot of them, list them all out, and they'll become milestones on your project. So that's requirements. So maybe at this stage, I know what I am agreeing to do, right? We have a shared understanding of what I'm going to do. What's the next problem, right? I kind of gave the clue away. So I know what I'm delivering, or I know what someone is promising to deliver me. I just don't know when it's going to show up, which is almost as bad. I mean, it's not quite as bad. You have a little more information, but you certainly don't have enough. So time scale. When will the change, the bug fix, the feature be done? And again, when I ask around, I get a range of answers. One is whatever, it'll be done sometime. Really, it's not an engineering answer. It just means I don't care. It's a priority problem, so it's not something I'm going to worry about. Soon, a wee while, gives me the impression it's going to happen sometime soon, but I've no real idea. A couple of weeks or a month, maybe a month or so. All right, how are these for? Do you guys give these answers? No, right? So I was seen as a bit of, I think it was pit bull was the name that was used, because I always ask people for a date. And that's apparently aggressive language. I'm saying, you give me a date. I'm not going to tell you a date, which is what a lot of people do, right? I say, give me a date, and I'll hold you to it. That's all, right? But it's a very effective way of getting a project done, right? So I have a date. What can go wrong now? I know what they're going to give me. They've given me a date. I just go into my machine and sit down and do some coding with some of the new stuff. No, there's a problem, because most engineers have misplaced optimism on timelines. Most of the time I say to an engineer, how long will it take to fix this? I say, it's a bug. They'll go, oh, I'd probably have that done in an hour or so, right? Meaning, if my editor is sitting up on that piece of code right now, I've got a check out of it, and I sit down on the right paragraph, I can add those lines and get it to compile, right? That's a pretty poor definition of done. Certainly not mine, right? Because you assume a best case scenario and are using a poor definition of done. Now, I like to see the happy programmer sitting there, yes, this is no problem. I'm going to knock this out in an hour in the afternoon. But it's kind of like, yeah, I got bad news. That's not my idea of done. So, and the other thing that will catch you off is you say, how long will this take? A day. All right, so we're doing a release next Wednesday. It's a Thursday, I'm good. And then on Wednesday, you're looking and saying, that bug is still in production. Whatever happened? Oh, I didn't start it yet, right? I never told you I was going to start it. I just told you how sized it was. I'm like, well, you could have maybe mentioned that you weren't going to work. You'd seen I was interested. All right, so I always ask when they're actually going to start it. And your time scale, right, the estimation, how good you are, the confidence interval, is somewhat determined by the problem domain you're in. Large projects with lots of things, it gets very spongy. Something small, you can be much more clinical on. So good time estimates, why bother, right? Seems like an unnecessary hassle for me as an engineer. Why do I need to do good time estimates? Well, you want to have trust with your customer, your stakeholders, so that they feel good about working with you, right? And when you ask them for a favor every so often, they're disposed to give it to you. It's not adversarial. So how do you give better estimates? What's the one thing you can do to give better estimates? Double your estimation? No, that's kind of been a bit slippery. All right. I'm not saying how do you get cover. All right. It's break changes down into smaller pieces, right? And estimate on those pieces, not some big, large piece. I've asked people, how long is this change going to take? I think 3 weeks, and I'll be code complete. And I say, can you break that down into all the pieces? Well, I can, but when I add that up, it's probably going to be 4 or 5 weeks, all right? Because you've taken some of the uncertainty out. So it's not a good thing, right? Break it into smaller pieces. Have the specific scope, right? The requirements and scope we talked about. And embrace empirical reality. This is something else that can be tough for people. I was in a group where we did scrums, and for 3 months, we put on 24 points of work. All right? Pretty ambitious. However, in them 3 months, we only ever did 12 to 14 points of work. And I said to the team, why are you putting 24 points of work on there when you know half will not get done? And in the end, the way they got out of it was, this is what we're aspiring to do, right? Well, I mean, I like the lofty goals, but, living on the outside, you're a black box. I need to know when it's actually getting done. And lean towards a little contingency fund for delays. Right? If you're doing a renovation of your home, and they say, that's going to be 50 grand, I'll need 5 grand extra just as a contingency fund, I'll probably end up using some of it. Right? If we're doing a project, have a contingency fund for time. Right? Now, not what someone over here said. If someone said, I'm renovating a house for 50K, I'll need a 50K contingency fund, I'll be like, you're out of your mind. So it should be 10, 15%. It's got to be a reasonable small slice. But you should have it there. And worst case, you deliver the project on time, well, then you've come in ahead of time. No one's going to fault you for doing something like that. And then the other thing that's very important is as time progresses on a project, as you make your way through a project, your initial estimates become more and more precise. I know now I'm halfway through this project, that's maybe a 4-week project. I'm 2 weeks into it. I can tell better at this stage where the end point is. It may have moved out, it may have moved in. It's probably moved out, but it may have moved in. And you can communicate 2 weeks before, we're not going to make that deadline, we'll need an extra week. As opposed to the night before, you say, hey, we're not going live. We got problems, all right? And we don't have even time to think about what we're doing, so we're going to hack the hell out of our solution to try and make it work, all right? So communicate this better information as early as possible. So why are we done? How are we for time? Half? Okay, good. Right, so I got to tell you, this is just a forewarning on this talk, right? There is a school of thought, never commit to anything concrete, right, or easily measurable. Be a bit slippery, because then you can't be held to account. And that being vague, but being vague, precise stuff like this is all about protecting yourself when things go wrong. Right? It's kind of like I want cover because I'm pretty sure this is going to go over a cliff, and I don't want to be riding the train when it goes over. Right? So it's not for doing positive outcomes, it's for just giving yourself cover. Right? This is not the talk you should be in. All right? I want to deliver. I am very product focused. In other words, I got to get the product to the customer, or I'm not providing that business value we talked about. All right? So with that, let's begin. So, I came up with this idea. Anyone hear of Maslow's survival pyramid of needs? All right? Where they say, look, human civilization has these layers that it has to do one before it moves up the ladder, right? So that it's food, heat, warmth, place to shelter, all right? So eating a rabbit in a cave, all right? Then you got the one on top of that, which is security. So you have a village, you have a wall, so you have security, health, stuff like this. You go up this pyramid, and at the top you have writing Shakespearean sonnets, self-actualization, right? But you have to do the lower ones first, right? You can't write a Shakespearean sonnet when you're running through the forest with a bear trying to eat you, and you're pretty hungry, right? It's like you're not thinking of that. So you've got to do the lower layers first. And I thought, you know what? There is an analog called a software engineering pyramid of needs. All right, and I'm going to start filling these things in this talk. So let's talk about development. Is that done? All right, has the change been verified and applied? And if it has, have you met the acceptance criteria for that change? Now that might be a small JIRA piece. Here's the work you're supposed to do in JIRA. It doesn't have to be a big, lofty company goal, but it again is precise about what you're trying to do. And have you met it fully or partially? All right, maybe you're like, look, I can't get it all done. I've got this much done, but that provides value, so I'm going to push that out now. All right, so it's not a complete loss. Has it passed all the tests that are driven by the validation system? That means is all the unit and integration tests that used to work still work? Right? Have we added tests for the new change we've done? Has it passed code review and been committed to the repository? Right? Code review stops crazy things getting into your code. Right? People doing very weird stuff. Right? And lots of times it's two friends committing their own stuff that gets a lot of strange stuff into a code base. So, is it being reviewed by more than one person? I always insist on 2 people to review. It stops the handshake effect, all right? And has it been merged into a package for production release? Right? Or is it just sitting in the repository? And if it has, when? Right? Is it ready for deployment? Can I take your change and deploy it? Right? And we have, I don't know, some people call it a fiction of code complete, because this is not code complete. If there's a problem in there, you're not code complete. But I guess it's initially code complete. You believe you've delivered V1 of the change. All right? So this here, have your development done. Who uses this version of done in their day-to-day when someone says, are you done? 2, 3, 4, maybe. Okay, there's a lot of people starting to put their hands up when other people put their hands up. All right, so I'm going to say maybe 12.5. All right. Yeah, it is development done. Have we hit the customer yet? Does anyone know about this? I mean, you're laboring on obscurity right now. There's no credit going to get to you from anyone who's looking at the system, right? So it is an important part, but you're not done. We have to look at the deployment. Is the deployment done? You know, I've said to people, well, is it? You know, is it done? I don't know. It's like I just put the thing out there. Well, when's it going to get into production? Are the changes deployed everywhere? What's the pace of deployment? I actually asked, when is it going to be deployed everywhere? And someone will backtrack and then give me the pace of deployment, because they don't know. They're like, well, it's going to be in QA, and it's going to get to beta. There's 3 production stages. So it's going to be like a month and a half from now. All right? And I go, a month and a half from now? I don't understand that. Can I have a date? Right? And they come back with a date. And I have something that I can say, okay, we're deployed on this date. If we're in a more complicated project, has it got any staggered dependencies? Is there some group that has to deploy their stuff for yours to work? And if so, I got to go and figure out and track them the exact same way. All right? And if they're late by a week, it pushes these guys up by a week, or these people by a week, and we get, right? I can tell early that my new time has pushed out, and I'll communicate it to the stakeholders. Oh, and any code freeze is imminent. I don't know. I get plagued by these a lot, where it's like, we had just had the election. It's like no code goes in when the election is going on, in case we all lose our minds and trade in strange ways, right? We're going to be okay. All right, so this here is deployment being done. All right, another stage. Are we done? Who uses this version of deployment? No one? Not a single person? One guy. Okay. I don't know if you're just trying to make me feel better. All right. Okay, so that's deployment done. Well, maybe you're like, there's some other guy taking care of that. But you should be wondering, is your change getting out there? Right? So you know when to set your alarm for 3 a.m. in the morning. All right, when someone calls you. Anyone here not know what a feature flag is? All right, feature flag is a software tool allowing us at runtime to turn on and off bits of new functionality, right? So we don't have to do a rollback. It's like it's like a circuit breaker in the code, an if statement, so that when we turn on new functionality and it goes badly, we can just turn back to what used to be there. All right? And I say here untested, but I mean it's never run in production, because that's what real engineers do with their testing, right? Production. Yeah. Hardcore production. No, it's a really bad idea, okay? So, it disables a specific, why? Why do we do this in the first place? We can disable a specific change. I know when I'm pushing changes into production, there's 10 other changes, maybe 2 critical fixes going in. And if my stuff is broken, I don't want them to have to roll everybody else's, including changes that maybe have a hard cut that I can't delay. So that's why we use them. So is the feature flag enablement done, right? Because I've just said that I might have that code everywhere, and this has happened to me. Have we got that out there? Yes. Deployed everywhere? Yes, we're good. I still see a bug. Oh, we didn't turn on the feature flag. Right? The code's not active. So until you turn on a feature flag, if you have them, your code's, I won't say useless, but it's not very useful. Right? So our feature flag's enabled everywhere in production. Right? What is the pace of the enablement? And when will that be complete? And again, I ask for dates on that. All right. And then there's another thing, well, when is that flag going to be removed? Because when I switch over, there's a whole dead branch of code that's just sitting there that's going to die in obscurity. I'm not sure if it meets the haunted graveyard definition, but I know I've tripped. I've gone in to try and refactor code in the middle of refactoring a bunch of code, and I find out right upstairs there's a feature flag that was changed 6 years ago, right, 2018. I'm like, all right, so let's go back to my pyramid. So I'm going to fill in the bottom row of this pyramid now. All right, here's what you need to be doing when you're putting changes into production. You need to be able to do all of this. All right, once you've done that, you have, congratulations, you've got survival of your code base. You can actually get a change into production that people will see. All right? So look, congratulations, you're a good coder. You're a good coder. All right? Says it up there. Now, I'm going to have a rationale here that why is survival in our code base not enough? Like, what more can there be to life than fixing bugs and putting new features in and just letting things rip, right, and seeing where the chips fall? Well, I'm going to say, and I'm not sure, I may have seen this out there, it's certainly a version of something I've seen out there, that any system where engineering is only concerned with feature changes and bug fixes will, over time, devolve into a complex, brittle, hard-to-manage code base. Anyone dispute that? All right. So efforts are needed to reverse the entropy in your code base. Otherwise, you end up with a legacy code base that you all complain about. All right? So let's go to code health basics. How do we keep code healthy? Well, one thing is software decommissioning. And again, you know I'm being very precise with my terms. What is decommissioning? It is the strategic process of retiring outdated software and its associated infrastructure. All right? Normally to have overall maintainability or efficiency of your code enhanced. Right? You're not adding features or fixing bugs. There's two types of decommissioning. All right. Anyone guess what the two types are? You can't say anything. You've seen my talk. All right. So one is there's code that's structurally never been able to be called. It's not as frequent. I come across a big block of code. You know, someone should have retired it ages ago, but it turns out that they wanted to leave it there just in case we wanted to come back and take a look, like a walk down memory lane and see how things used to be done. All right. Or they've taken a piece of code to put all the comments along it, just in case someone forgets how it used to be done. All right. So that stuff can be found with static analysis tools. All right, there's a couple of them on here. You can go look at it. But the other type is code that is never accessed with current input, meaning I don't believe this is ever used again. There's a particular trade that's coming from an exchange. I don't think they do that anymore. I think 4 years ago they said they weren't going to do that kind of trade. Right? So we monitor the usage in production, and after a certain length of time, when we're like just a little uncomfortable, we'll say we'll make the change. Right? We'll put a B-reg, or we'll put a feature flag around it. Okay? And the other thing is feature flag removal. Terrible, terrible business we have. I do believe that Clang could do something like this. I know in Bloomberg we have it that it's supposed to do that kind of thing, but I see lots of dead code for switches that were turned in 2016 and 2018. Not sure what went on that year. All right. So, is your decommissioning done? Well, is there any decommissioning needed? If I have replaced something, have I planned for the removal of whatever I've replaced? They can coexist side by side for a small amount of time, but I should have something on my backlog with some kind of time alarm on it that says this now needs to be decommissioned. I don't want to leave code in the code base that's not part of the active code that's used. Because when I go to do stuff like refactor, I try and refactor both sides of this because I'm not sure I can get rid of one. And it makes the job really hard. All right, so that's feature flag removal. So eliminate those dead branches. And removal of what I call bespoke functionality. Some of the systems I work in are probably older than some of you. all right? And I find that, they did a lot of write their own stuff. So we have like bools inside of classes of do I exist or something, right? Which is just an optional. Right? I have in-out pointers being pushed in and out, right? Instead of just saying, look, return something. They say, well, the bool that comes out tells me if the operation succeeded. It's like, so you're going to say you optionally get a result. It's like, okay, we'll just put it in an optional. These kind of things, right? A lot of times I see people searching in a loop through code, use find if. You want to say this thing has two types of things in, use partition. Don't go rotating once to pull out one type and rotating once to get the other. All right? Be familiar with your algorithms. There's plenty of talks about that. So that's decommissioning. All right, something that you should be doing to keep your code healthy, taking out the dead wood that's going to build up inside your code. So what is software refactoring? Because that's another thing we need to do for code health, right? It is the disciplined process of changing a system's software that does not alter the functionality of the code, but improves its internal structure, right? Sometimes efficiency, but the idea is that it becomes easier to work with. The code has kind of got tangled up with different people doing things in different ways or duplicating things, and you say, I'm going to go in there and make it all one easy-to-read piece. All right, but why is refactoring needed? I mean, why would we put in suboptimal solutions? Right? Well, we have this idea of tactical versus strategic change. Right? In other words, I need to get this thing fixed now, but I promise to come back and do a really nice implementation later. All right? And the main reasons for this happening inside your code base is time challenges. There's some kind of time pressure on you. Hey, production's on fire, I need a fix. Okay, all right. Hey, we mistimed this whole thing, and now we're supposed to deliver something, hack me my way to a solution. But refactoring time essentially wasn't budgeted. All right, it wasn't seen as something you need. You didn't have any kind of what do I call that thing? Like a contingency fund for it. And you had no time to research what was going on. So what happens is you duplicate chunks of code instead of properly refactoring into one solution. All right. And so, okay, there's one half of this is the person, writing the code, right, is putting in stuff that should be properly refactored. But there's a shared responsibility. There's people supposed to be reviewing this code and stopping this getting in. All right? It's not like as long as we don't write good code, or we all write good code, we're fine. That's why we have code reviews. You're supposed to find this kind of stuff. And I will tell you, over time, if you do not refactor your code, over time it's going to inevitably lead to a system rewrite. You're going to go to your management and say, I cannot work with this code anymore. And if you've just inherited that code in the last year, you got a real good case for, I don't know what these guys were drinking, right? But this is really terrible code that needs to be thrown away. I can't even begin to refactor this code, right? And I got to tell you, management doesn't like hearing the word rewrite because it generally fails. Because your idea of the problem is going to be a very simple idea of how it should work in your very toy implementation in your mind. Reality is always more complicated than what's in your head. And a piece of legacy code is like a stone that's been in a river. Over time, it's been worn smooth, right? It has all that arbitrariness, the tangle of reality, humans saying, yeah, do this, but in this other case, for no good reason, do it this way. All right? That's all in there. So is refactoring done? All right, is there any refactoring that I need to do due to recurring or duplicated patterns in the code? Right? Do I have low readability or maintainability in my code? Do I have all kinds of smells in the code? I won't go into them, right? But do we have overly complicated or redundant logic? I seen a piece of code that said, if true, do all of this, else, do all of this. Like, I actually went to the guy, I used git blame, and I said, why did you do this? I said, well, who reviewed your code? Because that's who I want to go after, not you. You know, you could tell me you were testing somebody. All right, so use of singletons. All right, I give a talk. My first talk here actually was retiring the singleton pattern, why over-reliance on globals and singletons is bad for your code. and how it makes them untestable. And large methods or classes, like a 10,000-line function should be broken up, these kind of things. We also want to remove the functionality that's now standardized. I talked about that, algorithms, optionals, expected. Use the tools the language has given you. Don't be writing your own stuff, or get familiar with them. We can also have a paradigm change. As the way business is done has completely changed. We used to focus on one area, and now we're focusing on something else. And it needs to go into the same code base. Right there, you may need to do refactoring, right, or a local re-engineering. And then the last thing is you have a thing called technical depreciation, which means that over time, code ages. It's not that you put something in the code, it's just that over time, code shows its age. Right? We have new ideas, new ways of doing things. All right? Now, anyone here work in a legacy code base? Oh, then you know what I mean, most of you. All right? So, let's go to technical debt. Am I down to 15 minutes? Yeah, okay. What is technical debt? Well, it's trading what? It's trading quality for speed. Essentially, it's the cost of reworking and fixing code in the future due to some kind of quick fix that we did now. And it's not just the undoing of that fix, it's working all other solutions around that fix. That's also the debt you're paying. All right? So, to me, I'm a simple man. To me, it's just unnecessary complexity in the code. And when I get some real fancy piece of template logic that I could write in a simple, very easy way, I look at that as someone injected technical debt in the code that puts a really complicated solution in what a simple one would do, and the next person coming along is going to take half a day figuring out what happened. So what causes people to do technical debt? I mean, why, I said it before, why would we put suboptimal solutions in a piece of code? We're engineers. We take pride, right? Engineering über alles, I think. Let's use my limited German. All right. Well, we have the deadlines in firefighting, which is kind of like stuff that may not be in your control. We have people getting way too clever, doing premature optimization. I looked at a code review just last week, and something was templated. It said, where is this templated than anything else? Well, it's not. But someone in the future might do it. I said, well, let the someone in the future templatize your class. All right. All right. Another thing is look, it's not just the people writing this. And junior engineers, we expect some of this. But they should be learning from you giving them a proper critique of their code, right? How you do it correctly. So again, it becomes a shared understanding of what is good code in our group, right? A lack of skills or a poor culture will also have a lot of tech debt coming in. Right? And the other thing is we can have organic growth. Like a system that was small and then grows large and you had 2 people working on it, it's probably sane looking. When you have 50 people working on it doing the same thing in different ways, it just organically grows. It's tech debt. All right? You have to combat it. Right? Poor documentation. Someone, I know you did, right? Documentation. Give documentation, write stuff down. You'd be surprised how effective it is. Right? Even if someone comes and says, look, you wrote this 8 months ago, it's completely wrong. Oh yeah, let me fix that up. All right? And all of this happens over a span of time. So it doesn't happen, it's not like you have big shifts. Normally it's just like I take the code base yesterday and today, I can't see much stuff. Today, 6 months from now, look at all the crap we let into the code base. Right? Who would do such a thing? So, there was a guy called Napton. Because a lot of times with tech debt, we're trading for speed, and we say, look, for now, it's temporary. I think this guy captured what temporary is in software engineering. He's actually a software engineer, right? It's like, there's nothing so permanent as a temporary decision, right? Words to live by. So when you make these temporary decisions, try and keep them temporary. So there are categories of technical debt, all right? Who thinks all tech debt is bad? Show of hands. Who thinks some debt is good? All right, that's maybe 3 to 1. All right, you're right. Right, there is what I call intentional tech debt. You take it on consciously for some strategic reason. my time to market. I need to get a feature out there. I need to beat the competition. All right? That is taking on tech debt strategically, and that's okay, as long as when you're taking on the debt, you're putting in the repayment terms of that debt right there and then. You say, I'm going to have it on my tech debt list. All right? So it's placed on a backlog, and I don't mean in the backlog where it never gets seen again, right? In a tech debt piece of your backlog that you go to, not occasionally, but in a schedule. All right? The other type of tech debt is unintentional, right? There's no strategy behind it. We're just doing a poor job. We fabricate a deadline in our head that's not really one, and there's no plan to mitigate it. And the same guy said, a project is not done until you go back and adjust whatever shortcuts you took as technical debt. And everybody agrees this is how we define done. All right. Who likes that definition of done? Man, who doesn't like it? All right, looks like half the audience hasn't a clue of whether they like it or not. All right. This is a real good definition. I wish we used it everywhere. I wish we taught it to people. Okay? So, how do I get a handle on tech debt? I can only get a handle if I track it. And that means I have to make a list, a tech debt list. And I'll put things like a description, but I'll say things like, what's the size of fixing this debt? What's the severity? And I mean the size as in small, medium, large, big, medium, little, right? It's just something to give you a kind of a handle because you haven't looked into it yet. But you need to be intentional with tech debt, meaning you add it to a list when suboptimal solutions are used. I had last quarter a PR with 3 other people who all said, we agree this is not the proper solution, and we're going to come back next quarter and fix it. And I said, let's put something on the backlog that says we're going to clean up this tech debt. And they would not do it because it felt like they were outing themselves about putting bad stuff into the code. As opposed to you're being responsible, it was like, we should not be saying we're putting something bad in the code. But that's not what you're doing. You're making the code base better. All right? And you need to keep it visible. It's no point putting it somewhere and forgetting about it. I guess tracking it's a little better than doing nothing. But you need to put it on your roadmaps. And I used to have on a team, I'd do a tech debt sprint once a quarter. So 6 sprints, they're 2 weeks, they're 2 weeks each. 2 weeks every quarter got put into tech debt, right? To clean up the stuff we didn't do correctly during the quarter. And you say, well, we didn't put any tech debt in. Well, great, then take the 2 weeks and do something nice for the code base. Right? But you need to advocate and champion this, right? You can't just leave it to management. Sorry, Nick. All right, you have to take, as an engineer, take responsibility for this kind of stuff. And lots of people will tell me, management will not allow me the time to do this. Well, they will if you parade the business risk in front of them, all right, how their time to market is so long, all right, and how we're dealing with a big maintenance load. I've had department heads say, why does it take this amount of time, like a month to get something into production, or 2 months, or whatever? It's like, because look, you got tech debt. It's sucking your resources so you can't actually work on what you need to. All right, so maintenance load, by the way, is how much time and effort your developers are doing and just like treading water. Okay, so that's tracking tech debt, all right, and getting rid of it, right? How do I prevent tech debt? So there's 2 ways of keeping that list short, right? One is to get stuff off it by mitigating. The other is not to put stuff in the first place. So have proper timeline planning. How do you get proper timeline planning? Knowing what you're supposed to deliver and when you're supposed to deliver it. We went over it in the first part of the talk. That's why I went to the trouble, by the way, all right? And I have proper code review guidelines and standards. Train your people on how to do a critical code review from an engineering point. There's a whole part of code reviews which is giving it in a nice way, not upsetting people, stuff like this, but actually being able to spot the problems so you can get to that part of your code review. Design reviews. All right, people shouldn't be hairing off in with single-person solutions and coming back, boom, here's the fix. Right. And tracking. If you're tracking tech debt, people don't want to go on that list, right? There's a sort of certain, so you're doing this, I've just done your code. It looks like a suboptimal solution. Let's put this on the tech debt list. No, just let me, I'll fix that up. All right, so you stop it just growing indiscriminately. And training, right? Training of all this stuff. Really, I don't think we do a great job of training our engineers or retooling them. And last is going to be the testing pillars I'm going to talk about. We should have unit integration and system because we maintain quality through testing, right? That's what we're trying to do when we bring testing into the code. Remember I said earlier about features have to be available, usable, and reliable, right? Well, that's what the testing does, keeps the quality of what you're delivering up. All right, you have 3 types. You guys probably all know this, right? Unit, which is mocking stuff out, close to the developer in time. It's easy to do problem solving in it, or easier. And usually you have exhaustive happy and unhappy path testing. All right, for integration testing, what we have is we stub out the executables, we bring our task up. We have these mock, usually Python tasks that are going to pretend that they're the dependencies. And we do mostly happy path testing. And then we have system testing at the end, which is the end-to-end. Nothing's mocked out. We'll just put synthetic data in. If it's trades, it's going to be dummy buyers and sellers. If it's where I am in Ticker Plant, it's an exchange that's not a real exchange. All right, so when we find problems in the functionality, are we leveraging the experience? In other words, are we creating tests in production for the next time this problem happens? So a problem happened in production, that's fine. Not a big deal, I'm going to say. Happens a second time in production, the question should be, why is this ever showing up again when we've seen it the first time we didn't put tests in? Right? Do we have adequate test coverage? And then here's the various types of coverage, right? What happens is they get increasingly long in both time, increasingly complex. So move your tests up this chain as much as you can. And try and keep the last guy out of your testing, right? Your customer. Right? Because if you take any of these away, they just migrate up the stack. And you automate testing because it's key. You don't want people looking at a screen, did something go wrong? You want when something goes wrong, you get an email, a ticket, something that says, hey, get over here now and fix or take a look at this problem. All right. So again, why is survival not enough? Well, that's why you need code health. Right? So I am now going to fill in the next layer of this pyramid. Right? These are the things you need to do for what? To have sustainability. Your code base is now sustainable. And if you do this, congratulations, you're an engineer now. You're not a coder. Right? Your career has moved up. Okay, so what's above this line, right? So look, here's a line here. All right, and because once you move further up this pyramid, there's a big change in emphasis. What do I mean by that? I mean, instead of being asked, are we done? Actually, instead of your boss telling you what to do, you start telling your boss what needs to be done. And he doesn't ask you, are we done? He asks you, are we prepared? Which really means, are you prepared? Are the people you're minding, I guess? The answer there is probably not, right? Probably not. If you want to know why, you'll have to hope Jens asks me back next year for part 2, right? Because I don't have time. So for a recap, what level of software engineering are you operating at? Are you a coder, fixing implementation, or fixing bugs and putting new features in? Not that that's bad. Fine, we need people that do that. Or are you an engineer that's using code-based health and sustainability are in your mind when you're driving the bottom layer of this pyramid? So to recap, when are you done? Well, you got to be specific on the scope of what you're doing. That means having milestones, acceptance criteria, and being very aware of scope creep. Time, a critical element, right? Deliverable to milestones, meaning you've broke your stuff down into smaller things, and having a contingency fund, a reasonable 10 to 15%, not 100. And then being intentional on tech debt, meaning you have remediation follow-through, right? As an engineer, you push your leader. Why are we not taking care of this tech debt we took on this quarter? So, when are you done? Well, to me, it's when it's everywhere in production. It's supported by the team, meaning I had a problem in production The only guy who knew about it was on a beach in Mexico, and we had to wait a week for him to come back, all right? So the team needs to know. You need to share information with your team. Tech debt is decreasing, or at least not increasing. You have maintainable code that's structured, and that means you have happy developers, which means that you retain your engineers, right? They don't like run out of your group because it's so horrible a place to work. And your users are happy, right? Your clients. And once your clients are happy, so is the business. All right. So finally, and in parting, I'm going to say this presentation is well and truly done. Thank you. Well, at least for part one. Thank you. Now, I realize the irony of me leaving no time for questions, right, in the scheduling of my talk. But you can always come to me afterwards. We're done, right? We don't have any time? All right. We're going to let the next speaker. But you can catch me in the hall. I'm here today, this evening at the bar, okay?